Hello everyone, welcome back to the channel. So I do know that I haven't been posting for the last 2 weeks about there because I was a bit occupied with university stuff, and my voice is a bit different if you realize, because I had sojourn for the past few days, but I'm better now and I'm back with another question to discuss with all of you. So today we'll be looking at it's a very old question from November 2007. Why 2007? Okay, let's not talk about that, okay? I just found an interesting question, which is the first question. It's this part that I find interesting and I feel like it's worth discussing. So, there we go. We'll be looking at question 1. And the best part of the question is actually Roman 2, but I will actually discuss the entire question. So without further ado, let's get started. First question, explain. What is meant by a radian? So this is something that you should know before you enter your exam hall, because it's definition. Not lose all these 2 marks, all these 1 marks. Please keep these marks. It will actually help you. So what's the definition? Radian is an angle subtended at the center of a circle by an arc that is equal in length to the radius of the circle. There you go. One simple sentence, you get your 2 marks already. Okay, next one, moving on. Roman 2. Why one complete revolution is equivalent to an angular displacement of 2 pi radians? Okay, so we know the length of an arc has a formula of S equals to R theta, right? So if you make theta as a subject, you'll get S over R, right? Just normal maths, you rearrange and you'll get theta equals to S over R. So we know for one complete revolution, S equals to 2 pi R, right? Why? Because S equals to R theta, right? So for one complete circle, your angle is 2 pi, and assuming that the radius of the circle is R, you will get S equals to 2 pi R. That is how I say that for one complete revolution, S equals to 2 pi R. Therefore, theta will be equivalent to 2 pi R divided by R. I sub inside this formula. So I got my S as 2 pi R, and like I say, assuming the circle has a radius of R, I put it as R. You can cancel out your R and you will get 2 pi radian. So since they ask why one complete revolution is equals to the angular displacement of 2 pi radian, it's best to show it to them. And someone, I know it's just 1 mark and you might be thinking why we have to show so much, but you better show more than show less, because it's 1 mark. So probably this whole thing is actually 1 mark. So it's good and it's best to show how it is said that one complete revolution is 2 pi radians. So first we start with the formula. You know that the length of arc as a formula of S equals to R theta. Then we make theta as a subject, do some maths, you'll get theta equals to S over R. Then we also know that for one complete revolution, your S will be equal to 2 pi R. Why? Because for one circle, your angle will be 2 pi. And assuming that you have a circle of a radius R, you'll get 2 pi R. So you got your S. Now you sub inside this formula back, you'll get theta equals to 2 pi R divided by R. R can be cancelled out. You have proven that for one complete revolution, theta is 2 pi radians. There you go. Get your 1 mark. Okay, now B. An elastic cord has an unextended length of 13 cm. One end of the cord is attached to a fixed point C. Okay, a small mass of weight 5 Newton is hung from the free end of the cord. The cord extends to a length of 14.8 cm as shown in figure 1.1. So when this small mass of weight 5 Newton is hung from the free end, it's basically hung at this point, the cord extends. So the original length of the cord is 13 cm. This is the original length. And the extended length when the cord is hung freely at this point, it's 14.8 cm. Okay. The cord and mass are now made to rotate at a constant angular speed omega in a vertical plane about point C. That means the small mass is going to move in a vertical circle, right? Something like this. Going to move in a vertical circle because they said in a vertical plane. So when the cord is vertical and above C, its length is unextended. Its length is the unextended length of 13 cm as shown in figure 1.2. Where's figure 1.2? Oh, here. Okay, so they said when the cord is vertical and above C, basically it's above here, the length is unextended, which is 13 cm. That means it's back to its origin. So when it's above C, it goes back to its original length, which is 13 cm. Okay. Okay. So a few things to take note here. 13 cm is original length, 14.8 when it's hung freely at the bottom of point C. And when it moves in a vertical circle, and when it reaches a point above the point C, it goes back to its original length, which is 13 cm. Okay. First question. Show that the angular speed omega of the cord and mass is 8.7 radian per second. Okay. So, if we look at this figure 1.2, we can see that the only thing we have here would be our weight. Now, if your question is why is there no tension? Because this 13 cm is unextended. It is the original length. So when you are in the original length, nothing is extended. Of course, there wouldn't be any tension, right? So that is why there is no tension for this particular figure. There's only weight. And since it's moving in a vertical circle, we know there is something called centripetal force. However, it's also important to note that centripetal force is a resultant force. So it's a result of a force. So in this case, centripetal force is equals to your weight only, because the only force here we have is our weight. If let's say it is not 13 centimeter here, perhaps it's 15 centimeter for instance, therefore that means you will have your tension because you are extended. You have an extension, that means you have a tension. So your centripetal force would instead be equal to tension plus the weight at this point if it's an extended length. But in this case, they said when it's above point C, it goes back to its original length. Therefore, your centripetal force is equals to your weight. Okay, so with that information, we can actually solve Roman 1. So centripetal force is equals to weight. Also, another thing to mention, when you write this in exam, it's better to write in the full form. That means you write it as centripetal force equals to weight. Because the examiner doesn't know what do you mean by FC and W, assuming they don't know anything. Because some people, they don't write centripetal force as FC, they just write it as F. So different people have a different way of writing. So what do you mean by that? The examiner might not know. So it's best to actually write the full form, centripetal force and weight. So don't make them guess, because they need to see whether you understand that centripetal force is a resultant force. So it's best to write centripetal force equals to weight. When you are practicing at home, doing some past year paper, then you can write FC is equals to W. But when it's actual exam, especially when the shown question or proof question, it's best to write full form. It's the safest way I would suggest. Yeah. Okay, so going back, Fc equals to W, which is centripetal force equals to weight. So we know there's a formula mr omega square equals to mg. Weight is equals to mg. M can be cut off. You get r omega square equals to g. Your radius would be 13 centimeter as given here, and also be aware that it is in centimeter. You must change it to meter. So 13 times 10 to the power of negative 2 omega square is what you want to find. Your gravitational acceleration is 9.81. Also, another thing to be aware of, if you are doing further mathematics, this part, please be very careful, because gravitational acceleration in further mathematics for further mechanics, they round it off to 10 meter per second, that you can use 10 meter per second for all your calculation. But when it comes to physics, it is a bit more accurate. You have to use 9.81. So do not get confused. Make sure you know which paper you are writing, you are doing, and use the appropriate gravitational acceleration. This is a physics paper, so use 9.81. If it's further mechanics, then it's 10 meter per second. Okay, so I wanted to mention that to be careful, because it happens sometimes, right? So yeah. So then you'll get your omega equals to 8.7 radians per second. You will actually get plus minus because it's a square and you bring the other side as square root, but they said it is angular speed. We know that speed is a scalar quantity, therefore plus minus can be omitted. It's just a positive value, 8.7 radians per second. Okay, right, now to the best part of the question, Roman 2. It's 4 marks also, you know. Okay, but it's actually doable if you understand how it works. So the chord and mass rotate so that the chord is vertically below C, as shown in figure 1.3. Figure 1.3. Vertically below, oh, this is the one. Vertically below C. Okay. Your mass is here. Alright. Calculate the length L of the chord, assuming it obeys Hooke's law. They want us to find what is L. Okay. So let's analyze this figure 1.3. So this length L is definitely an extended length. Right, even if when you just compare between figure 1.2 and 1.3, you can realize that it's actually an extended length. So when it's an extended length, ideally means you have extension. And when you have extension, that means you got tension. Right, so in this diagram, if we were to label our tension and weight, your weight is this. This would be your tension. Yep. So the next question to ask is it tension plus weight, or is it tension minus weight? So let's look at our net force. So we know that this mass is moving in a vertical circle. Therefore, the net force is acted towards the center of the circle. In other words, your centripetal force is acting towards the center of the circle. So if your centripetal force is acting towards the center of a circle, in this case, your net force is acting upwards. So that means your equation would be tension minus W. Because when your net force is acting upwards, your tension would be greater. Tension minus W. So centripetal force is equals to tension minus W. And if let's say like I mentioned here just now, let's say it goes up after a vertical circle, perhaps it reaches here, and let's say they say at this point the length is 15 cm. So it's extended, right? Extended means you have a tension. That means you have both tension and weight. Then in this case, your net force is acting towards the center of circle. Yes, because centripetal force is acting towards the center of circle. It's moving in a circle. And in that case, T plus W will give you a centripetal force. So a centripetal force is greater on top, and it's lesser at the bottom. Okay, another thing to take note of, if let's say, in this question they did not ask, if let's say they ask, at which point will the string snap first? If let's say it was moved very fast, which point will the string snap first? Okay, I think it's not a string, it's a cord, right? Yeah, okay, sorry. Which point would the elastic cord snap first? Your answer would be bottom. At the bottom. Because if you were to rearrange this equation, you will get tension equals to centripetal force plus weight. At this part, if you were to rearrange, you'll get centripetal force minus weight. So if you see, which part has a greater tension? The bottom part. So that is why the bottom part will snap first. Yeah, so it's good to know this also, because they might ask. Because they just want to see whether you understand or not. So yeah, coming back to the question. So we were looking at this bottom part. Okay, let me erase some things. Looking at this bottom part here, right? So since the centripetal force is acting towards the center, the net force is acting towards the center, which is towards point C. The equation will be centripetal force equals to tension minus W. Your weight lah. Because it's acting upwards. So your tension minus W. Because tension is greater here. Tension minus W. Your weight. Okay. So we have one nice equation. Let's write that here. FC. So when solving this type of question, writing FC wouldn't really be a problem, honestly. Because what matters is you know how to substitute the values well. Yeah. So FC equals to T minus W. We know that FC is mr omega square. T is your tension. Tension is ideally force of the string, and they did say it obeys Hooke's law. So it's Kx minus mg. So before we substitute, let's see, do we have all the values or not? Do we have m? Yeah, we would have m, because we know the weight of the mass is 5 Newton. We use W equals to mg, make m the subject. You'll get your m, okay? You have your radius. Your radius is your L here, which is what you're going to find, okay? Do we have our omega? Yep, 8.7. We have calculated from the previous question. Do we have our K, spring constant? In this case, our Cots constant. Not spring, sorry, Cots constant. Nope, we do not have. But can we find? Of course we can find. How? Okay. We can find using this. Because in this diagram, we have tension. Because 14.8 is an extended line. And we have our weight. And they did say it's hung from a free end. It's not moving, nothing, it's just there. That means it's in equilibrium position. So we can say T equals to W and solve further. Can we use figure 1.2 to find the Cots constant? No. Because 13 cm is the original line. There's no extension here. So you cannot actually find anything. Okay. So we can find our K. We can find our X also. M has been found also here. G is our gravitational acceleration. So we have all the values. Now let's find our values before we substitute in. So let's start with finding our mass. Okay. So we know W, can do it side here. Okay, let's do this here. You know W equals to mg. You want to find your m, it's just W over g. M is your mass, what you're going to find. Your weight is 5 Newton, given in the question. Where is it? Here. Let me highlight for you so it's clear. Okay. 5 divided by 9.81. Then your calculator, you will get 0.5097 kg. Okay. Now let's find our K. T equals to Kx x, right? That's what you know. But in this case, since it's hung freely, we know that tension is equal to the weight. So K is what you're going to find. Your extension would be 14.8 minus the original length, which is 13 centimeter. So 14.8 minus 13. Don't forget to times 10 to the power of negative 2 because it's in centimeters. Your weight is 5 Newton, right? Because they already give that it is 5 Newton. So calculate your K. You would get K equals to 277.78. Okay. Basically, it's Newton per meter if you want to write a unit lah. Newton per meter. So we got our K, we got our mass. We can now calculate our L. Okay, so let's calculate our L. Okay, you know what? Let me use a different color for this so that you can see. Okay, let's go with green now. Okay. I mean, you can't choose color in exam, so it doesn't matter actually. But yeah, I just wanted to do a different color. Centripetal force, let's write the formula first so that we know what to sub in. M is 0.5097. Radius is your L. Omega square is 8.7 square. Don't forget to square. Don't forget, okay? Oops. Always remember, don't forget to square. 277.78. Okay, I think I'm running out of space. Okay. In exam, kindly allocate your space well, yeah? Yeah. Because you can't write further than this line. They won't read one. So, yeah, allocate your space well. Don't be like me. Please allocate it well. Okay. K. X. Your X would be length L minus 0.13. Why? Because this is your extended length, right? You want to find your extension for this particular scenario, which is for figure 1.3. Your length is your extended length. Not your length is your extended length. Your L is your extended length. Your L here is your extended length. Original length is 13 cm. I just straight away convert it to meter, 0.13. Don't go and put this inside here. No. It's two different things. Here, we are looking at this diagram. It's the same chord. That is why we have the same K. But the extension is different. Because here you have length L. Okay. Minus, I'm going to write it down here. mg 0.5097. G is 9.81. Okay. So, we do our math. Okay, let's calculate one by one. Please calculate one by one. Do not do it too fast because you might miss some values. 38.579. And always, as I mentioned, more than 2 significant figures between calculation. Final answer, you can give to 2 significant figures. This is to ensure accuracy. Yep. Equals to, oops, wait, I forgot my L. Okay, let's calculate this. This one, we have to open up the bracket, okay. 277.78 times 0.13, 36.1114. Okay. Minus 0.5097 multiplied by 9.81. Hey, why would I even do this? Oh my god, I just realized. Oh my god. You don't have to do this actually. Because you already know your weight is 5 Newton, what? So you just straight away write as 5. Why did I even... Oh my god. My goodness. Just write as 5. Okay. Just write as 5 straight. You don't have to calculate it. Oh my god. I just realized. Don't do that in exam. The examiner is going to laugh at you when you write that. Okay, so let's group our like terms, basically those with L, I bring it to the left hand side, and the constants, just the value, I just maintain it on the right. 5791 minus 277.78 and 2009L equals to, so the negative will eventually cancel out lah. Negative 41.1114. So your L, do your math. You'll get 0.1719 meters. Be aware that your final answer, they want it in centimeter. So don't go excitedly write 0.1719 meter. So 0.1719 meter, when you convert it to centimeter, you will get 17 point, this is actually actually yeah, quite right, 17.2. Yep. Right? Yeah, correct. I'm going to double check things, So it is 17.2 centimeter. That is your final answer. Got your 4 marks already. Okay, so let's have an overview back. Look back at what did we just do. So first thing is we analyze the diagram. Okay, this diagram. So since this is an extended length, L is an extended length, we know that we have tension and we know we have weight. The next thing we see was how would our equation be formed? Is it T minus W or is it T plus W? So we know our net force, which is our centripetal force, is acting towards the center of the circle because you're moving in a vertical circle. Therefore, your net force is acting upwards. So your tension must minus your weight. So centripetal force is tension minus weight. You have that. Then we realize that we need to find some values, which is we need to find our K, we had to find our M. So we found that first before we substitute. So you get your mass, get your Cots constant, then you substitute your value inside. Also, please be aware, extension here is based on this diagram because you're finding the L of this diagram, right? Then minus 5, just put 5 newtons straight, honestly. Don't go and put mg actually calculated it. So they only give you 5 newtons, just use 5 newtons. I don't know why I did mg just now. Then normal maths, you'll get a final answer as 0.1719 meters. Be aware that your final answer, they want it in centimeters. So make sure to convert in centimeter. And you'll get 7.2 cm. Okay. So if you understand how to form your equation, everything would be easy from there onwards. And you'll easily get your 4 marks. Just be careful how you find your Cots constant. You cannot use figure 1.2. Again, why? Because there is no extension. You can use this. That's the reason why they give it. They won't simply give you one. Yeah. So that's about it for today's video. I hope you learned something new today on how to form equation, a bit on centripetal force, and also the fact that centripetal force is a resultant force is something that is very important to understand. That centripetal force is not a standalone force, it's a net force, or you want to call it as resultant force. So both are same thing. Yeah. So that's all for today's video, and I'll see you in the next one. Remember to stay hydrated and drink a lot of water so that you don't get sojo like me. I think it's just the weather, honestly. I don't think the water was the issue, it's just the weather. So anyways, bye bye, and I'll see you in the next one.